Hello guys, how are you today? So today I'll be solving only the questions of CQD chapter 9. Okay, this is the notes. So we'll start with CQD 21 grid. Describe the structure of the solid ionic compound NaBr. First of all, we know if it's an ionic compound, okay, that means it is existing first of all as a lattice. Now what about this lattice? This lattice is composed of a positive ion, a negative ion, positive, negative, positive, negative, positive, negative, etc. like this. Okay, and it's gonna be like multiple layers and so on. So they need us to describe the structure of this ionic compound. Very simply, we say it's a lattice or a lattice formed of oppositely charged. We're gonna separate the ions. They are Na plus and Br minus. So formed of oppositely charged Na plus and Br minus ions. Each ion is surrounded by a group of ions of opposite charges bonded to them via static attractions and ionic bonding. So the forces or the bondings in between the ionic compounds, they are called electrostatic. Okay, that's pretty much it for CQD 21. Now we move on to exercise number 1. Which of the following are true about ionic compounds, the properties? So first of all, they are brittle. This is true. They are not ductile, they are not malleable, but they do form a lattice structure. They are hard, they have high melting points and high boiling points. They are good conductors, but not in all states, and they form regularly shaped crystals. So very simply, ionic compounds are brittle, lattice structure hard, they have high boiling and melting points. They are good conductors, but not in all states, and they form regularly shaped crystals. Moving on to CQD number 18, they need us to explain why NaCl is a non-conductor of electricity, while when it is melted it becomes a good electrolyte. So what happens is that the ionic bonds or the electrostatic forces between the Na plus and the Cl minus, they are so strong, okay, that they're only facing each other. So it's not gonna cause a current to flow because they're gonna like neutralize each other in some sense. So it's not gonna cause a current to flow. So the electrostatic force between the positive and negative ions do not allow the current to flow or the motion of electrons, okay? However, when they become molten or it is aqueous, okay, the Na plus will separate from the Cl minus, and so then the electric current can flow in between them. And so this is why when they are solid ionic crystals, their electrostatic forces causes the bonds to be extremely strong, so the electricity will not be able to flow through them. So now we move on to CQD number 11. Okay. They told us magnesium reacts with chlorine to form magnesium chloride. In the lattice of magnesium chloride, the ratio of magnesium ions to chloride ions is 1 to 2. Explain the term lattice. So very simply, they are just writing words, okay? It's all words they're talking about, and then in the end, they tell us explain the term lattice. Very simply, the word lattice means a regularly regularly shaped pattern, but here since we're talking about magnesium chloride, it's MgCl2, so we are talking about an ionic crystal, so it's a regularly shaped pattern of ions, okay, which in this case is gonna be Mg2 plus and Cl minus. Moving on to CQD number 14. So here they're asking us, explain why an aqueous solution of sugar is a non-electrolyte while that of NaCl is a good electrolyte. Very simply, sugar is not an ionic compound. Okay, so it's not ionic, it doesn't have ions. Okay, so it does not have any positive or negative charge that will allow the flow or the current to flow through them. Whereas NaCl, it is made of ions, Na plus, Cl minus. So NaCl as a solid will not work, but if you make it molten or aqueous, then yes, it's gonna split, okay? Because the ions will then be able to carry the electric current. And that's pretty much it for CQD number 14. Moving on to CQD number 20. So here they said describe metallic bonding. Very simply, metallic bonding is what? Metallic bonding is a strong electrostatic force, okay? Or it's a strong electrostatic attraction between positive ions and the sea of electrons. So now we are gonna discover how. Okay, so very simply, you have, here is the positive ions, and this over here is the sea of electrons. So you have negative. So you're gonna put positive, 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 positive. Okay, so the electron, of course, is gonna cause a force of attraction. Now this force of attraction is an electrostatic force. And these positive ions that are surrounding the single electron, they are positive ions, whereas the electron is called the sea of electrons. Okay? Alright, so if you were to write it in terms of words, it's a strong electrostatic attraction between the positive ions, which are cations, in a mobile or in a sea of mobile electrons. So we move on to CQD number 4. They said explain the following observation. Sulfur is a non-conductor element while sodium is a conductor of heat and electricity. Why is this? Very simply, sulfur is a non-conductor because it has no free electrons. It has no free electrons. Whereas sodium, definitely, it is a metal because it has free electrons. This by far is the simplest way you can describe it. If they want you to explain it more, so here they said explain, so what you're gonna do is you're gonna write sulfur has no free electrons, meaning that it cannot allow the current or the electric current to flow through it. Whereas sodium, I don't know if I said sodium, I meant sulfur if I said sodium, but sodium has free electrons, so this allows the electric current to move through it, because the electrons are delocalized and they can move and whatever. Now explain why silver is a shiny element. Now very simply, it is a shiny element because the free electrons or the sea of electrons, they capture light, okay? So because they capture the light, they will reflect it or re-emit it, and this causes what? A shine. So very simply, silver is a shiny element because the free electrons capture the light, they reflect the light, and this is what causes the shine. So explain why sulfur is brittle while copper is ductile and malleable. Why sulfur, is brittle. Now, brittle means it's easy to break, whereas ductile and malleable means it's hard to break. Okay, very simply, we can say because the forces of sulfur are van der Waals forces, which are the weakest forces that we learned of. Okay, so their forces are van der Waals forces, so they are weak, and if you apply a force on it, it is gonna break. Whereas the forces applied on copper are metallic forces or metallic bonding forces, which is electrostatic forces. These are really, really strong, so it's really hard to break them. So you need a lot of energy to break the copper. Okay, CQD number 7 grid. Give 4 properties of metal. Very simply, they are excellent conductors of electricity, okay, they have free moving electrons, They are malleable, meaning it's hard to break them. They are also ductile, so ductile and malleable. And they have a shine. That's pretty much it. So now we move on to exercise 2. They said, which of the following substances are the intermolecular forces mainly metallic? So very simply, Na. Why? Because we know sodium is a metal, H2 is gas, O2 is gas, carbon is also a gas, but it's a non-metal. Okay? So where do you usually find metallic elements in the periodic table? It's always on the left-hand side of the periodic table. Now, is it easy for metals to lose electrons? Very simply, yes. Why? Because, we have Na+, we have Mg2+, so they are losing their electrons. So definitely it's easy because usually they have a few valence electrons on their shells, okay? And this allows them to lose their electrons so they can attain the noble gas configuration. As a result, can they act as oxidizing agents or reducing agents? If you lose electrons, then you are undergoing oxidation. And if you're undergoing oxidation, then you are a reducing agent. So definitely they are reducing agents. So we move on to exercise number 3. Which of the following substances conducts electricity in the sodium state? In the solid state? It's definitely potassium because it's the only metal. This is an ion. This is network solid, ion, a non-metal, an ion. So the only metal is potassium. So it's the only thing that can conduct electricity in the solid state. Now, what is meant by metallic bonding? Again, it is the strong electrostatic forces between cations and sea of electrons. Okay, and that is it for part A. Moving on to part B. Many of the physical properties of metal can be explained using the idea of the sea or cloud of electrons. Okay. And finally, part C lists some elements that are conductors, definitely metals. So examples are copper, silver, gold, anything that is a metal. So now we move on to CQD19 grid. So they said, describe the structure of a network solid and give 2 examples on such solids. Very simply, a network solid is a giant 3D structure made of millions of atoms or molecules held together covalently, meaning they share electrons, okay? And this is what makes the network solid very strong, because they're sharing electrons. Now, to give 2 examples on such solids, we have diamond and SiO2. Okay, you can put any other 2 solids, for example, graphite, silicon IV, quartz, whatever, Now we move on to CQD22 top. Which of the following is not a common property for both diamonds and silica? So first of all, both diamonds and silica, they form giant covalent structures. They are both hard substances, okay? They both have relatively high melting points, this is true. They both have cage-like structures, this is also true. Now, the only difference is that their atoms is surrounded by 4 covalent bonds. Because diamonds, yes, their atoms are surrounded by 4 covalent bonds, but silica, its atom is surrounded by 4 oxygen bond, but 2 silicon bonds. So it's not 4 covalent bonds. This is if we're talking about SiO2. Okay, so definitely D is the answer because it's not a common property for both diamonds and silica. Moving on to CQD number 2. Explain the following observation. Sulfur melts at a much lower temperature than graphite. Very simply, sulfur has van der Waal forces, whereas graphite has covalent bonds, and covalent bonds need a lot of energy so that they are broken, whereas sulfur needs very weak energy, which is van der Waal forces, to melt them, or yeah. Explain why phosphorus is a brittle element while diamond is hard. It's probably again because of the directional bonding. So very simply, phosphorus has again van der Waal forces. Okay, so that's what causes it to break easily, whereas diamond has covalent bondings, which makes it hard. Now, what particles make up the crystal lattice of a metric solid? Okay, you have two types of particles. They're either atoms, so a bunch of atoms, or molecules. So for example, SiO2, this is a molecule. And then you have diamond, which is made out entirely out of atoms and whatever. So that's pretty much it for exercise 5. Moving on to exercise number 6. Which of the following substances are network solids? First thing we have carbon and diamond, not helium, not hydrogen, carbon and graphite, silicon dioxide, and quartz. So we move on to CQD number 9. They said germanium has a similar structure to that of diamond. Describe the structure of germanium. If it has a similar structure to that of diamond, that means it has a tetrahedral arrangement in where each germanium atom is bonded to 4 other germanium atoms. Okay, and they are covalent bonds, so it will form what? Hexagons. Okay. Now, silicon dioxide, SiO2, has similar structure to diamond. Describe the structure of silicon dioxide. You may use a diagram if necessary. Again, silicon dioxide is going to be a tetrahedral structure. Okay, so each Si is bonded to 4 oxygen, and each oxygen is bonded to 2 silicon. So it is 2 to 4 and 1 to 2. This is if you simplify it. Okay, so that's pretty much it for CQD number 9. Moving on to CQD number 1. They need us to what? To specify the type of forces. So definitely H2 is van der Waals, also helium, van der Waals. O2 is also van der Waals. C is covalent bonding. Na is metallic bonding. P4 is again van der Waals, and S8 is van der Waals. In exercise 7, they're telling us specify the major intermolecular forces that exist in each of the following. So what I think is that they are all what? They are all except some. So yani this, okay, these 4, they are all what? Van der Waal forces, whereas potassium K and aluminium Al are gonna be metallic forces, and then finally the last one, which is diamond, it is a covalent bonding. Okay, moving on to CQD number 10. They need us to separate these based on the bonds that exist in them. So very simply, these are van der Waals forces. Okay, they have something else in the answer key. We didn't take it, so please don't worry about it. So it's only van der Waals forces. NaCl is an ionic bonding or ionic forces, and SiO2 is covalent bonding or covalent forces. Now in exercise 8, they asked us to specify the major intermolecular forces that exist in a crystal of each of the following. So they put them in 3 groups for us. So the first group, first of all, it is van der Waals forces. The second group, okay, it is ionic bonding or ionic forces. The third group is definitely covalent bonding, which is covalent forces. Moving on to exercise number 9, they said which of the following are the properties of a substance of van der Waal force? We know van der Waal force are very weak, so it's not hard, it's soft. It does have a low melting point. It's a weak conductor of electricity. It has a low heat of vaporization, which means a low boiling point, and yeah, that's pretty much it. Moving on to exercise number 10, they said what particles make up the crystal lattice of a molecular substance? Molecules, This is very easy. And that means iodine is a molecular solid. A crystal of iodine is made up of molecules. That's pretty much it. Now moving on to CQD number 12, they need us to fill in the blanks. So very simply, CO2 is a molecular solid. I2 is also a molecular solid. KCl is an ionic solid. Diamond is a network solid. H2O is a molecular solid. Li is metallic. It's just a single metallic. Xe is a single atom, so we call it atomic, and SiO2 is a network solid. Now the particles, by the particles they mean what makes up each type of solid. So molecular is definitely molecules, same here and here. Okay, so molecular is molecules. Ionic is gonna be ions. Network is gonna be atoms. Okay, same for this network over here. And atoms is also atoms. And finally, metallic is the positive ions in the sea of electrons. Okay, so we move on to CQD number 13. They said, from the above list, choose an element that is a noble gas, meaning it has an electronic configuration that ends with 8. So definitely it is gonna be D, because D ends with 8. It has 8 valence electrons. Is a soft metal with a low density. So if it is a soft metal with a low density, it has to be in group 1. So how do we check the group? So we check the last digit, so 1. And the only thing in group 1 is E. Can form covalent compound with element A. Element A has 5 electrons. It needs to gain, it doesn't need to gain, it needs to share electrons. So it can definitely share electrons with a non-metal, because it is a non-metal. So very simply, 4 is a non-metal, 7 is a non-metal. However, 2 is a metal, so we're not gonna choose it. So we can say B or F. Has a giant molecular solid structure similar to diamond. So very simply, if it has a structure similar to diamond, it should be in the same group as carbon. So that means group 4. This is in group 4. The answer over here is B. Moving on to the last question. Can form they mean negative ions on the type of X3-. That means it just needs to gain 3 electrons. It will have the noble gas configuration. So our answer is A. So D, E, B or F, B and A. Moving on to part B. Okay, they said draw a diagram that represents the formula of this compound. Elements C and F, they form an ionic compound. Okay, they told us that use C to represent, or use dot to represent C and X to represent F. First of all, let us find out what C and F are. C has atomic number of 20. So if you look at the periodic table, calcium has an atomic number of 20. F has an atomic number of 2 plus 8 plus 18 plus 18 plus 7. So that is 53. So it is iodine. So 53, iodine. So we're dealing with Ca2 plus and I minus. So Ca2 plus, I minus. Now because we are dealing with an ionic compound, we cannot represent it by the sharing of electrons. So instead, we're gonna put Ca, okay? And you have definitely the option to choose if you want to put the valence electrons or not. Do not put them like this, like how I just put them. Start north, east, south, west. North, east, south, west. Like this. Okay? And then we're gonna separate here and here. And here we have I and here we have I. Why did I put 2 I's? Because Ca is 2 plus. That means logically we're supposed to have 2 I's if it is only 1 minus. So now I has an electronic configuration, if you remember, of 7. So it has 1, 2, 3, 4, 5, 6, and 7. Same here. 1, 2, 3, 4, 5, 6, and 7. Now what it is missing is the electron. So it will gain an electron from Ca and Ca. And like that, Ca has the configuration of noble gas, and same goes for it. Sorry, the iodine. Okay, now in part C, they need us to draw a diagram representing the arrangement of valence electrons in molecule of nitrogen trichloride. Okay, so nitrogen trichloride is gonna be like this. Nitrogen is 3 plus, we know. And here we're talking about what? We're talking about covalent bonds or van der Waals bonds or van der Waals. Okay, and Cl minus. So what's gonna happen is we're gonna take Na. We know that sorry, it's not Na, it's N. And if you do its electronic configuration, it's 2, 5. So it has 1, 2, 3, 4, and 5. That means here we have 1 from Cl, because Cl has the number of valence electrons as 7. So it's going to be 1, 2, 3, 4, 5, 6, and 7 is here. Then also Cl, 1, 2, 3, 4, 5, 6, and 7. And as well here, 1, 2, 3, 4, 5, 6, and 7. And as you can see, it formed the bonds in the intersection. And that's pretty much it for part C. Now moving on to CQD number 23 top. Very simply, they told us which metal is which substance is a metal. It's definitely E, because it's a good conductor. It has a high melting point of boiling point. When it's a solid, it's a good conductor. When it's a liquid, it's a good conductor, and it's insoluble in water, so it's E. Here you just have to look at the table. Then for which substances are ionic compounds? Ionic compounds, they are good conductors in liquid, but they are not good conductors in when they are solid, and they have high boiling points. In this case, it's gonna be A and B. Why it is not E? Because E is what is a metal. It cannot be an ionic compound if it's a metal. Now for part C, which substance conducts electricity in an aqueous solution? Definitely it is ionic substances. Okay, but here there is a small trick. It is the solubility in water. So aqueous solution means solubility in water. You have two options. You have this one or this one. This one is insoluble in water, so directly we choose this one, which is A. Which substance is a gas at room temperature? It's the one that has a really, really low melting point, which is D. Which is a liquid at room temperature. Here it's supposed to have a low melting point but a high boiling point, so it's gonna be C. And finally, which of the following is a network solid? I believe it is F, because it has a very high melting and boiling point, and it's non-conductor in all states. Now, the student suggests that the network solid in the above table is graphite. Do you agree with him? No, because graphite is an electrical conductor. That's pretty much it. Moving on to CQD number 24. Potassium nitride melts at 800 degrees Celsius, whereas nitrogen trifluoride melts at minus 200 degrees Celsius. Explain in terms of attractive forces why potassium nitride has a much higher melting point than nitrogen trifluoride. Very simply, because potassium nitride has ionic bonding in it, whereas nitrogen trifluoride has van der Waals forces. And you know that, and not you know, we know that van der Waals forces is a very weak force. So very simply, it does not need a lot of heat or a lot of energy for it to melt the element. Whereas if it's ionic, covalent, network solid, these you need really, really high temperatures to melt them. That's it for today. Thank you guys for watching. I hope you enjoyed and have a wonderful day.